Okay, so after D-type climates, kind of going poleward, we have E-type climates, our polar climates. And not so surprisingly, these would be associated with the polar cell. We said the polar cell begins in both hemispheres at about 60 degrees latitude, then poleward. So these polar climates are confined to that region. This says 70 degrees poleward, but so we have three, I believe three subcategories. We have just the plain polar climates, and then we have tundra, ET, and then we have ice polar, which is, I believe, EF. So I don't know. It's got some beautiful pictures coming up here of these sort of climates. The next slide kind of says what a tundra is, but in a tundra we have these sort of moss-like vegetation, very stubby sort of things near the ground. And remember that near the poles, there are times of the years near the winter solstices that there is no sunlight, that as the Earth rotates on its axis, these regions receive no sunlight throughout the course of the day. So, I don't know, it should be kind of a different sort of deal. So, tundras, in general, I mentioned they have these sort of mossy-like plants. There are, I believe, some trees, but permafrost is also a predominant feature of the tundras. Permafrost means permanent, the ground is permanently frosted for, like this criteria says on the slide, about 2 years. And permafrost actually, the thawing of the permafrost is one of the indications that that would suggest that surface temperatures are warming on Earth. But so permafrost is permanently frozen soil, basically. So here are the pretty pictures I talked about. Down here, showing you some permafrost here. Arctic ice cap. The third type of polar climate is the ice cap, or EF. And it's an ice cap. By definition, these would include ice sheets that are in excess of a mile thick. We talked about katabatic winds earlier. We talked about small-scale winds or medium-scale winds. And katabatic winds are those that fall off of a plateau after dense air kind of builds up. It falls off the plateau and creates that downslope wind. In the polar cell, generally speaking, there isn't much precipitation. The difference between a glacier and an iceberg is broken off of a glacier and floats in the water. You probably already knew that. But this would be considered a polar climate here. And so these are some climate diagrams for some polar type climates, and you can see how very short and squatty this blue line down here indicating the amount of precipitation throughout the year that this location in Alaska receives. And check this out, check out Greenland's precipitation. They're not showing any precipitation throughout the year. Isn't that interesting? Now the red line is the temperature throughout the year, and all of these temperature scales have been the same on all these climate diagrams for this chapter. So remember the other climate diagrams for like the A-type were up here, and now here we have this cold. This cold being, let's see, that's negative 22 degrees Fahrenheit down at the bottom of the scales, these scales. So it's a beautiful photo of the Alaskan tundra from your textbook. To kind of wrap things up, oh the irony, our own, trying to mine our own resources here in the United States. This is the Alaskan pipeline. Afraid I don't have a lot to add to this, but very interesting.